Today we will discuss how this keyword works and how you can benefit from it using it in different places. And we will finally discuss object-oriented programming in JavaScript. Before we start talking about object-oriented programming, let me give you an analogy from real life. So in real life, let's say, for example, you have an idea about a muffin that has a specific height and a specific width. And you want to create the same muffin multiple times, such that the difference from muffin to another is the number of raisins that are put on top and their placement. For example, this one had 2 raisins, but this one has only 1. The third one could have 3 raisins, and so on. But they all share the same height and the same width. Doing this for large number of muffins will eventually make you make mistakes when it comes to specifying the height or the width. Let's say, for example, you want to create 1,000 of muffins of this type. So they wouldn't have a consistent shape and you would make mistakes. Another cooler way of achieving the same result is by using the muffin pen. So it will allow you to have consistent results, and all you have to do is you have to specify the difference from one muffin to another, which is the number of raisins and their placement. So the equivalent of a muffin pen in JavaScript and in many object-oriented programming languages is called classes. And in the class, you define a new type. So you create a type. And from that type, you will create multiple instances. Just like when using the muffin pen, you can think of the muffin pen as the type of the muffin that you are going to use. And then you would have simple muffins created out of that muffin pen. So each muffin is an instance of that type. Similarly, in JavaScript, you define new types using classes. And from that class, you would have multiple instances, how many instances you want. And so classes will allow you to create as many instances as you want easily. In JavaScript, and since everything is an object, there are 2 types of objects. There's an object type, and there's the object instance. And there's the difference. So object instances are created from a single object type. So all of these object instances are created from one single object type. So let's say, for example, you have a system where you want to have multiple users in it. The way to program this using object literals will become very hard because you would have to write a lot of repetitive code. Since you already know that each user has, for example, an email and a name and a function to retrieve these 2 properties, you would be writing a lot of repetitive code that would be harder to maintain, and it would look like what we call spaghetti code. So take a look at this. This is very repetitive. A better way of doing this is by using classes, as we said. The way you declare new object types in JavaScript is by using classes. So I can say class, and then I can specify the name of my class. I will call it user. And then I need to specify what actions should I take every time I need to create an object. And inside this constructor method, I will provide all the properties that belong to this object. So the value of this would be an empty object. And we say this.name, which means assign a name property to this new object instance. For now, let us give it a static value. So we say this.name and this.email. And if you want to have methods inside your objects so that you can call them, you just type in the name of your method. Similarly, like when you did with object literals, you say get information, and I need to return a string. So this.email plus this.name. And now the way you create objects, which are, as we said, object instances from this object type, we say let u1, which stands for user1, and then we say new, and then we create the name object. Then a new object will be created called u1, so let us console the value of u1. And if I say new my script, take a look at that. My object is of type a user, and it has 2 properties, name and email. I can call get information by pressing that, and it automatically detects the properties of my objects and the method that it contains. and it retrieved the email and the name. Now the problem is that all of my users have the same name and email, and we don't want that. We want something more dynamic. What we can do is that we can say, whenever you create a new object instance, please provide us with the email and the name. And then what we're going to do is that we're going to assign this name that is passed in arguments to the newly created object. And then when you create a new object, you need to pass the email and the parameter. So I can say for this user, I give it this email and this name. And for the second user right here, we give him another value. It has this. And now let us console log the two objects. And take a look at that. Each object now has his own name and email. Some of you already noticed, if you have been console logging and checking in the browser, is that you would get this weird property called prototype. And it appears a lot in objects. So it appears in every kind of object. You would get this property called prototype. So what is this thing actually called, prototype? And why, when we expand it, in this case, we get this get info right here. So why not get information is not placed with the other properties of my object? So let us equip ourselves with the necessary concepts to properly understand how JavaScript achieves object-oriented programming. The first thing that we will understand is this keyword. This keyword was created to make it easier for you to retrieve some context information of the code that you are currently executing. This in JavaScript will always return an object, and it depends on how you use this keyword. If you use it in some places, it returns a specific object, and if you use it in another way and use it in other places, it will probably return a different object. A general rule of understanding this when used inside functions or methods is that this will always return the object that called it. If I have, for example, a simple object literal with one property and one method, this method is called getInformation, and I'm simply returning this just to check the value that it is holding. And I simply took this method and put it outside of the object. So now it is a global function. So let us see the differences. If I call object.getInformation, execute my script, this returned the current object that the method belongs to. If you use this inside a method, not a function, it will always return the object that the method belongs to. Now let us execute the global function and console log the value just to see the difference. So if I execute my script, we see that this is being bound to the global object. Let's get back to the rule to understand what happened. We said that this will always return the object that called the function or method. In this case, we have function, not a method, which means it is declared globally. So which object called getInformation? In this case, we are calling it globally, which means that's if we are saying global dot getInformation. And so the object that called getInformation is the global object, and that's why this refers to the global object. Now let us see an example where using this will help us properly retrieve the correct context information and will allow us to write a more reusable code. If we have two objects, the first one is factory and the second is user. Both have the same method, which is getInformation, and it is implemented the same. They will just return the name property. It would be really cool if we could avoid this repetition of writing the same function in two different objects. Maybe we have more than one object. Maybe we have 10 objects that implement the same function. What we can do is that we can take this function and declare it globally. So let us delete the function from the second object. And then I want to change the context of calling getInformation, and I want to bind this to the object that's called this gets information. There's a helpful method called the call method. So let me declare a result variable that will hold the result of get information. I want to call get information, and I press start and I say call. This is a built-in function that the JavaScript engine automatically injects to every function. And now inside the arguments, I should provide the object that I want to use this method. So I can say .call, and I provide it with the factory object later on. Now if I console log the value of result, then I save and I execute my script, I will get a factory. But if I change this object right here and put another object later on, I use user, re-execute my script, I will get a user. That's because what is happening under the hood is that the call method binds this object to the object that you provided in the arguments. Now let's look at another use case of using this. And this time we'll look at callbacks and arrow functions. We have a simple object literal called article, and it has two properties. The first one is the title property, and the second holds the list of contributors to this article. And I have a method called get contributors. It's a simple function that will loop through the list of these contributors and print the title and the contributor name. So I'm run node my script. It will say the value of this title would be undefined. That's because callback functions, if not properly assigned to a property to an object, they will always hold the value of the global object. Now if we change this to an arrow function, we will see that it will be working. So let us change it to an arrow function, open the console, and re-execute the script, and now it is working. That's because arrow functions, they just simply go to the parent scope where they were lexically defined. In this case, they were lexically defined within a method. And we said that methods will set the value of this to the current object that it belongs to. So when we used an arrow function inside a method, it simply went up the scope chain and it took whatever value it was set to this. And in this case, the current object. And that's why it is working in arrow function and it doesn't work when using regular functions. Which means if I have a reference to this arrow function from the global scope, if I copy this arrow function and put it globally and declare a reference, let us call it my arrow, and pass this arrow function as a callback, and re-execute my script. Now it is not working. That's because, as we said, it goes up the scope chain, goes to the parent scope, and it just copies the value of this. In this case, the parent scope is the global scope. And in the global scope, this variable is set to the global object. The last thing that you need to know about this is that if you use the new keyword in front of a class or in front of a function, as we will see in a second, this will be mapped to an empty object. And that's why we use this dot and we specify the properties of that object, because new will bind this to a new object that we're going to create, and then you use this to reference that object, and then you add properties to it. So if I have a simple class called user, and inside the constructor, let me console log the value of this. Open the terminal and execute, and it will return an empty object of type user. That's why we can add properties using this keyword. Now, as I said, you can use the new keyword with classes, and you can use them with functions. So that's the cool thing about JavaScript, let's say. And we provide the name of our function, we provide the parameters, open the curly braces, and simply console log the value of this. Open the terminal and we execute your script, and it will give you an empty object. So the job of the new keyword, whenever used with classes or functions, will always map this to a new object. If I delete this new keyword, now this should be bind to the global object. As you can see, it returned the global object. But we don't obviously want that. We want to create a new object. So essentially, classes are just syntactic sugar over functions. What is happening under the hood is that for each class, there is a function that is called with a new keyword. These functions, they become an object type. So as we can see in the console, we see we have a new object of type user. And functions that create types are called constructor functions. So we can achieve the same effect or the same results using just functions. So I can say this.name and provide it a name passed through parameters. And I can say this.email is equal to email that is passed from parameters. Let me pass an actual name and email. And now let me console log the value of u1, which is my user. If I save and open the console and execute the script, now we have our user that has a name and an email. And I can create different users, of course, and it will work exactly the same as we did in classes. And now we have a different user. There are two ways of adding functions to an object type while using constructor functions. The first way is by adding them using properties. In this case, I just created a new property called getInformation and I assigned it a function. If I go to the browser just to get better visualization, I get email and I get three properties: email, getInformation, and name. But this isn't what happened when we used classes. When we used classes, all of our functions were put inside the prototype object. We need to understand the advantages of doing that and what are the disadvantages of doing it this way. The problem of adding functions as properties is that the function code will be copied for each newly created object. But in this case, the function code, it is exactly the same. So it would be better if all objects have a reference to the same function and they can all call it. That would be way much more efficient than having the function copied inside each object, since it is the same. But in the case of the name and email, each object should have its own proper name and email because it will be different. Before I show you how we can achieve that level of code reusability, you need to understand how inheritance works in JavaScript and how JavaScript organizes objects under the hood. JavaScript has an object called object with capital O. So this is the name of an object that holds some methods. These methods are shared across every other object. So every object that is created in JavaScript, whether it be an array, an object literal, or anything that you can think of as an object, has access to these methods. But how does JavaScript achieve that? It achieves that by inheritance. So for each object type that is created, JavaScript automatically creates another object called prototype. This prototype object is just a property inside this object type and it is called prototype. This prototype object that is created will hold all the code that shouldn't be copied each time you create a new object instance. So instead of copying code and put it inside every object instance, we have a property called proto that will reference this prototype. So you can put all the code that should be shared between all object instances in here. You can put all the functions or the variables that you don't want to be copied each time you create a new object. But even object types also have this property called proto. So the difference between an object type and an object instance is that object types have a property called prototype, and object instances, they just have a property called proto. We will talk about this proto right here, reference, and where it points in the case of object types. So this prototype object right here, it is an object instance. It is not an object type, which means it must have a property called proto. And this proto should point to the prototype of this object instance. And in this case, it points to object, which is the parent object of all objects. And that's why when you look for a method inside your object instance, it will first fetch its prototype, whether it is contained in its prototype. And if it doesn't, it will go to the prototype of that prototype. So it is a chain of prototype references that goes all the way up to this object right here. But even this parent object, it also has a proto property, which is a reference, but in this case, it doesn't have another prototype. It references null. Now let us talk about proto in the case of object types. They just, since object types are created by calling a constructor function, which means there is an object for functions that allows you to create this object type. And it has all the methods that you need to create new objects. And it also has proto. And this proto will point to the parent object. So let us add our get information inside that prototype. I can say user, and then I say prototype. Then I can say get info, and let me copy and paste this code. If I save and go back to the browser, reload, and then I expand this user object, now I can see that get information is no longer a property for my object, but it is put inside the prototype object. So I have a reference called prototype to the prototype object. And inside that prototype object, I have get information. So this get information is shared across all objects. And it works because, so if I say user.get information, it will retrieve the specific information for that user. Values won't be conflicted because this, as we said, if it is being put inside a method, it will always refer to the object that called that method. In this case, I have u2 calling get information and u1 calling get information. So there won't be a conflict of values. So if I save and go back, I get the proper name and email for each object. Let's say that in my system, I have two types of users. So I have a regular user with a name and email, and then a get information function. And I have another type of user, which is called admin. Admin has the same properties as every other user and the same function, which is to retrieve the information, but it has something more. Let's say that it has the ability, for example, to delete other users, and it has another property, which is, let's say, role. I can create my admin by retyping the same properties and retype all of this again for the new type. But that would be code repetition, and that's bad. I want more code reusability. What I can do is that I can call this function directly inside admin, but without saying the new keyword. So it will act as a regular function. But what I need to do, I need to bind this to the newly created object, which is admin. I can say user dot call, and use the call method, and I can bind this to the newly created object, because when I call admin using new keyword, this will point to an empty object, and I'm saying just bind this, that it is inside the user function, to the newly created object. And let me pass the parameter, which is the name and the email, and the parameters to come from the provided arguments. if I create an admin and I call it admin, and I say new, open, I provide the name and the email. So if I console log my admin, I save, then I go back to the console, I get my object, which is of type admin, and it has a name and an email, and of course a prototype. So as I said, my admin has also this get information function, but it also has something more. So let us first avoid that code reusability by trying to add this get information without retyping. Now what I want to do is that I want to add a new property and I call it role. So I say this.role and let's say admin. Now this property won't be added to my two users because it only exists within this constructor function. If I go back to the browser, I reload and I go back and I get role. So if I say u1 and expand, it doesn't have this property, obviously. Now what I want to do, I want to get this information right here. In other words, my admin should inherit all the functionality of user. So as we said, whenever we have something that should be shared, it should be put inside the prototype. So I say admin.prototype, but in this case, I don't say that gets information because that would be repetitive. I say object.create, and I want to create a new object. And inside the parameters, I can specify which prototype or which object should my admin inherit from. In this case, it should inherit all the functions that exist from the user. So it's a user.prototype. But let me show you what I did in here by just simply drawing it. Now, I have the user object type. And as I said, each object type has a property called prototype. And it also has proto. We're not interested in this one. We are interested in its prototype. So JavaScript already created prototype. This holds the method called getInformation. So I want this shared. I don't want to retype this again. And I have my admin. My admin also is an object type. So it must have a property called prototype that has the prototype object, exactly like user, and it also has proto. What I want to do, and what I did by saying objects.create, is that I created this object by using objects.create, and inside it, I put the reference of its proto not pointing to the object, to the parent object, which is called object. So instead of pointing there, I just point it here to this prototype, so that whenever object instances that are created from admin start looking for the getInfo method, they will first start fetching in the prototype, and if it doesn't exist, they will start fetching inside the prototype of this prototype, and so they will get the getInformation method. And of course we have this prototype pointing to object. So that's essentially what is happening under the hood. Now I have one single function for both object types. I have one single function called getInformation that will work for all object instances that are created from the admin object type and the object instances that are created from the user type. If I save, then I go back and reload. Let me expand the object. So I go to the prototype. We see that it is already inheriting from user. So it is pointing to user. And we get this nested prototype because we don't want to pass directly the prototype, because we don't want our other users to have the same functionality that admin should have. So this is the way we should implement inheritance. And if I expand this, now I have getInformation. So if I say admin .get info, it should work. It should retrieve the informations of my admin. And it did. Look at that. It returned the name and the email. Now what I want to do, I want to add to my prototype of admin another function which is called delete user. So let's say it has the ability to delete users. And I simply pass it the function of deleting users. So let us just console log a simple message. It's a user deleted. If I go back and refresh, now we can see that we have delete user, but other users, regular users, won't have this function. If I say user1, I press enter, and I go to the prototype, it only has get information, but my admin has delete user. So let's see this prototype chain. So if I say admin, and I say 2 underscores proto, this should return the prototype of admin. And as you can see, we got the prototype, which has the delete user and another reference to the prototype that have the get information. So if I say that's 2 underscores proto, this should return me the user prototype. And now I have the user prototype only. And then if I say that's 2 underscores proto, this should return the object prototype, because even the user prototype was created from the object prototype. If I reload, I get the object prototype. Now these are the common functions that every single object has. So every object inherits in a way or another from the parent object of all objects, which is called object. If I go right here and I expand this, it should return null. And as you can see, it returns null. If I say take the prototype of object and say proto, this should return null. So this is the end of the prototype chain. So when you use classes, all of this prototype thing is abstracted away from you. So if you come from a language such as Java or C#, a regular or the mainstream object-oriented languages, they are not prototype based. In JavaScript, they introduced classes just to make you comfortable, and they abstracted away all of this prototype thing. But it is really important, because every time you console log an object, you will encounter that prototype reference, and it is annoying to see it all the time without understanding what it is. So you can mess up your code without even knowing it. Now in here, I just rewrote the same example but using classes. So I said class admin, and I said extends. And now you already know what is happening under the hood. You are just creating a new object for the prototype, and you are passing the parent what you want to inherit from. So you already know all the details of just one single keyword. So all of this is just syntactic sugar. We say extends user, and then we have inside the constructor. Then we are calling the upper constructor by saying super, and provide it with name and email. And we have a new variable called role, and it just simply works.